In this lesson, we are going to learn about unbalanced forces and Newton's second law of motion, where we will learn how to compute the resultant force and acceleration. Take note that many examination questions on dynamics involves computation of resultant force and acceleration of objects acted on by unbalanced forces. In lesson 1, we learned that when two or more forces acting on an object are not balanced, there will be a resultant force, and the object will move towards the direction of the resultant force. This actually brings us to the second law of motion instituted by Sir Isaac Newton. Newton's second law of motion states that when an object is acted on by two unequal forces in opposite directions, the object accelerates in the direction of the larger force. The product of the mass and acceleration of the object is equals to the resultant force. Therefore, deriving from Newton's second law of motion, the formula of resultant force is given by F equals to ma, where F is the resultant force, m is the mass of the object, and a is the acceleration of the object. Now let's look at how we can apply this formula to compute the resultant force and acceleration. In this slide, we have a school bag being pulled along the table by a force F1. There is a frictional force F2 that opposes the motion. As the two forces are not equal, and F1 being greater than the frictional force F2, the school bag could move to the right with a resultant force that is equals to F1 minus F2. According to Newton's second law, this resultant force is also equals to the product of its mass and its acceleration a. Take note of this very important concept, as most questions are set based on this. The best way to learn the concept is to start applying it to solve questions. Here's a typical type of question that will be asked in examination. A car of mass 1000 kg starts from rest and moves with an acceleration of 2 meters per square second. The total resistive force that opposes the car's motion is 1200 Newton. A. Calculate the resultant force acting on the car, and B. Calculate the driving force due to the engine of the car. So let's do our workings here. We are supposed to calculate the resultant force and the driving force. We are told that the total resistive force is 1200 Newton, and we are also given its mass and acceleration. With these two parameters, according to Newton's second law of motion, we can already compute the resultant force, which is 2000 Newton. This resultant force is a result of the two unbalanced forces, the driving force of the car's engine and the total resistive forces that opposes the car's motion. Hence, the resultant force can also be found by taking the driving force minus the resistive forces. Rearranging this equation, we can compute the driving force to be 3200 Newton. To conclude, for this lesson, we have learned about unbalanced forces producing a resultant force, causing the object to accelerate in the direction of the resultant force. It is a situation where Newton's second law of motion applies. So the acceleration and resultant force is governed by the relation F equals to ma. If an object is at rest, when unbalanced forces act on it, the resultant force will cause the object to move and accelerate in the direction of the resultant force. If the object is in motion, the object's direction may change as it accelerates in the direction of the resultant force.